Okay, today in section 8.8 we're going to talk about systems of linear equations. Okay, well, first off, what in the world is a system of linear equations? Really simple. A system of linear equations consists of two or more linear equations with the same variables. So basically I'm looking at two lines and they both have an x and a y, or they both have an a and a b. Now, if we're talking about the solution of a linear system, it's going to be an ordered pair that is a solution of each equation in the system. So this would probably be easier to look at as a picture. So if I have a coordinate grid, and I've got this line here, and I've got this line here, so I've got two lines, this is a system of linear equations. Now my solution to the system is going to be this point right here. It's going to be the point at which they cross. Now it kind of makes sense that this point here is also a point that is a solution for each equation, and it's going to be the only point that is a solution to the system. Okay, so let's figure out how we even know whether an ordered pair is a solution to the linear system. So I have my system, y equals 3x minus 8 and y equals 2x minus 5, and my point is going to be 3, 1. Now the definition for the solution to a system of linear equations is that it is a solution for both equations. Now remember, this 3, 1 is an x, y. So what I'm going to do is I'm going to take each of my equations, I'm going to plug 3 in for x, 1 in for y, and I'm going to see if it works. So for that first one, if I plug 1 in for y, 3 in for x, I'm checking. Are these equal? And hopefully you see that they are equal if I know how to write. 1 equals 1. So it works. It checks out. Now, great dandy if it works for one, but it's not a solution to the system unless it works for both. So I also have to check the second system here. So if I plug 1 in for y, 3 in for x, and I'm checking, are these equivalent? And it turns out that they are. If it checks out for both of them, then yes, it is a solution. Let's try y equals negative 5x plus 9 and 6x minus y equals 11, and the point we're checking is 0, 9. So this time plug 0 in for x and 9 in for y. So let's look at that first line. If I plug 9 in for y, 0 in for x, checking. Does it work? Well, it does. Okay, so it checks out on my first line. Let's try our second one. Okay, be very, very careful because I'm going to plug 0 in for x, 9 in for y, and I'm checking. Does that equal? And hopefully you see that no, it does not equal. If this happens, it's not a solution. It has to work for both of my equations. Okay, so that's a way that we can check your answers. Now, if we want to actually solve this system, the way that we do this is we can graph both lines, and we're going to find the point at which they cross. Okay, so our first example we're going to look at the line y equals 3x minus 8 and y equals 2x minus 5. So ultimately what we're going to do is we're going to graph these two lines, and we're going to graph them on the same coordinate plane. So in order to graph these lines, I need to find my slope and my y-intercept. So for this first line, my slope is 3, the y-intercept is negative 8. For my second line, the slope is 2, the y-intercept is negative 5. So on the same coordinate grid, we are going to plot these two lines. So give ourselves a little bit of room here. Okay, so let's graph this first red line here. So we're going to start at my y-intercept, which is at negative 8. Now from negative 8, my slope tells me I need to rise 3, run 1. Now in the past, we really only plotted 2 points, but I want to kind of reiterate that my slope is the same anywhere on my line. So if I wanted to, I could plot an endless number of points. So from this point here, I could go up 3 more and rise 1 more. And I could go up 3 more and run 1 more. So notice that I know you're going to have to bear with my drawing, but they should all be on the same line. So if we do the same thing with my second line, my y-intercept is at -5. This time my slope tells me to rise 2, run 1, rise 2, run 1, rise 2, run 1. And obviously my axis wasn't drawn very well, but you notice hopefully that they do cross. They cross at this point here. That point as an ordered pair is my solution. And as an ordered pair, that point is 3, 1. Okay, let's try another one. Okay, my first line is going to be y equals x plus 1, and the second line, y equals -1/2 x minus 2. Okay, so on that first line, let's identify the slope in the y-intercept. I have a slope of 1 and a y-intercept of 1. My second line, I have a slope of -1/2 and a y-intercept of -2. Okay, now our next job is to graph both of these lines. So, let's give ourselves, maybe do a little bit better job of drawing this time. Okay, for that red line, we need to plot my y-intercept at 1, and then I'm going to rise 1, run 1, rise 1, run 1, rise 1, run 1. Now, what I can actually do, because if I keep extending it that way, that's okay, but I could also go in the opposite direction. I could go down 1, left 1, and notice that it's still on the same line. Down 1, left 1, down 1, left 1, and they are all on the same line. Okay, from my blue line, we're going to plot the y-intercept at -2. This time my slope tells me to go down 1, right 2. Down 1, right 2. Now hopefully you notice that they're never going to cross over there, so instead let's rise 1, run -2. Rise 1, run -2. They're all still on the same line, and notice they do cross. They cross right here, and that point as an ordered pair is -2, -1. Okay, these last two. Let's try y equals -4x plus 1 and y equals 5 minus 4x. Okay, so for my first line, I have a slope of -4, a y-intercept of 1. For my second line, it's a little mixed around, but remember my slope is the coefficient in front of x, so my slope is -4, my y-intercept is 5. Okay, now to graph these ones, go ahead and draw your coordinate grid. Give yourself a little room on either side. Okay, for the red line, my y-intercept is at 1. My slope is -4 over 1, so I'm going to rise -4, run 1. Or I could rise 4, run -1. Remember, either way works. Okay, for my second line, this time I have a y-intercept of 5. And I'm going to rise -4, run 1. Rise -4, run 1. Now hopefully you noticed that these lines are parallel and they're never going to cross. If they're parallel lines, they're never going to cross. So there's no solution. That's what you would write. If you find that you have parallel lines, you just write no solution. Okay, and last one. This time we're going to have to do a little bit of work. Let's say I have 4y equals x plus 1 and 2x equals 8y minus 2. Okay, now remember the first thing that we really need to do is make sure it's in y-intercept or slope-intercept form. So for the first equation, I need to divide everything by a 4. I get y equals 1/4 x plus 1/4, where I have a slope of 1/4, a y-intercept of 1/4. And for my second line, I need to get it in y equals, so if I'm solving for this y here, maybe I start by adding 2 to both sides. So I have 2x plus 2 equals 8y, and then I can divide everything by an 8. And I'm going to flip it around so my y is first. So y equals 1/4 x plus 1/4. So I have a slope of 1/4, a y-intercept of 1/4. Now these ones are going to be a little bit trickier to graph, just because of the fractions, but that's okay. For my red line, my y-intercept is at 1/4, so it's going to be right in between two of my points. It's not going to lie exactly on a point. Now, from my y-intercept, I need to rise 1, run 4. So when you rise 1, you should end up with just right above the 1, right? And then connect our points. There we go. Okay, on my second line, I also have a y-intercept at 1/4, and I have a slope of 1/4. So hopefully you notice that these are the exact same line. If they're the exact same line, there are infinitely many solutions. This is a solution, this is a solution, this is a solution. There are a ton of solutions. There are infinitely many solutions, and that would be your answer.